So, good afternoon. Thank you for stopping by. My name is Jacques Bessoudo, and I work at NVIDIA in the DGX product group, which is essentially the area that focuses on the deep learning systems. And so, I'm going to walk you through some learnings that we've had with building not just servers but actual infrastructure for deep learning and AI. And I'll show you some of the outcomes as well as the partnership that we have with TVN and how they've helped us really come to a nice little package that we'll talk about in just a minute. So, a lot of enterprises, when they're considering starting an AI adventure, they look at different options on how to, either acquire hardware or actually work with a partner and, a cloud service to investigate what it takes to actually develop their own environment for deep learning. And so, a lot of what happens is you end up reaching out to one of these cloud vendors and working with them and is that?
Yeah.
Okay, I'll try and keep it.
Yeah, it's got to say really close.
Okay, sorry. So the idea is we're trying to, some of these cloud vendors, we partner with them, and the idea is you have to work on your models and define what you want to do up front and make sure that you know what you're doing before you upload all your models or your data to the cloud so that you can process the data and get the results you're looking for, do the research, or find the right trends in the market or whatever you're goes into. Now what happens is that typically this becomes a little bit expensive when you're doing it over and over again and you're experimenting, right? And so what we're seeing is that many customers end up bringing this infrastructure to their own premises to be able to do this over and over iteratively without any limitations of their budget or their OpEx, and so those constraints go away, and also the researchers can go in different directions, leveraging different types of data with all the flexibility in the world. Sometimes you pick the data that you think you want to use for your research and you upload it to the cloud, and it turns out that you're missing some, or that you have the wrong data set, etc., and that takes time, etc. So what ends up happening is that I'm not saying the cloud is a bad thing in any way, shape, or form. There's, I think, a really good aspect of the cloud is once you have your models trained and your environment set up, you can actually go back to the cloud and deploy your models and actually do a lot of it could be a really big, large worldwide deployment and have all that knowledge close to your customers so you can provide very fast insights and very fast returns to your customers and have quick interactions and quick deployment of data to the customer directly by leveraging the benefits of it. So anyway, I think that there's some very interesting aspects to both areas, but today we're going to focus more on the infrastructure deployment on premise. So research indicates that more and more industry, the companies that are focused on deploying AI have really benefited from it, and they've actually seen profits boost up to 15% already, even as they're just starting to deploy these technologies for their customers. And so this has been great insight because it makes other enterprises interested in deploying this type of infrastructure and learning more about what they can do with all the data they've been collecting for the last few years. Building the huge data collections, whether it's their customers or from their research, right? And so essentially, the other type of research that we highlight here is, well, why aren't many companies actually deploying all this AI infrastructure to actually gain those benefits and gain that extra revenue? And it turns out that many of them have expressed that 40% of them have expressed that infrastructure is the actual impediment for them to get to that point where they have the AI infrastructure that they need. So at NVIDIA, we decided to take an approach of solving it internally for ourselves and see what it would take to build this infrastructure. And that way, we thought it would be good to, document it and let these learnings, provide these learnings to our customers, so that everybody can benefit from them. And so Some of the challenges we found is that there's a lot of guesswork when you're designing this infrastructure. First of all, there's so many vendors. There's so many, not just hardware vendors, but there's software components and there's frameworks and there's so many components to all the pieces that are needed that a lot of it ends up being in lots of different drawing boards. And guess what? You may come up with an answer, but then you test it out, and you have to go back to the drawing board later on anyway. So it's an iterative process, right? And there's a lot of input from many places, and so that's something to keep in mind. Also, once you find that you have the right design for your infrastructure, you actually go ahead and deploy it, and there's all kinds of infrastructure challenges, maybe not even related to the solution itself. They may be just the amount of power you need in the data center, the kind of cooling that you're going to do, right? And all these details start really becoming facts once you put your design together and you start getting all the pieces in place and doing the research. And so that's something that really ends up being cumbersome, and sometimes we've seen customers that get all the infrastructure ready, but they can't actually turn it on because it's just it wasn't planned ahead of time. And then the other thing is, there's, like I said, different vendors, and they have different strategies for achieving different goals. And so some of them have better expertise in one area, and some of them have better expertise in the enterprise versus research. And so that's something else that we take into account, and so we try to help solve some of these challenges. So some of the platform considerations are interesting. For example, usually researchers, they don't care about infrastructure. All they want is it to be there, and so they can start loading in models and doing things with it and becoming productive with it. And so sometimes that pressure comes down on IT, and IT has to find a solution quickly, and that may not be the best approach to designing a multi-million-dollar infrastructure investment, right? And so that's something to consider when you're starting out on this journey. The other thing is when you're basically trying to get an AI or deep learning infrastructure going, you really want to make sure that if the workload is going to be GPU focused, for example, which is kind of what we're focused on today, you really want to make sure that most of your investment goes into the GPU's infrastructure, right? And that the GPUs are actually going to give you the most return possible. So what does that mean? Well, it means that if you're investing in GPUs, you don't want to invest on a bunch of infrastructure for the GPU that isn't going to be used for the workloads that you're using. The other thing is, if you're going to buy a bunch of GPUs which are pricey, you want to make sure that they are communicating not just with each other, but also with other with your sources of data, for example, as efficiently as possible, right? And so all those things have to be considered in terms of the features that you need to look for your infrastructure. And then obviously having a reasonable total cost of ownership that will fit within your budget is pretty important too. So the idea is to keep all those three in check. Now, what we did is, we looked at all the layers in the solution. We started obviously with all the hardware, which involves the GPUs, the servers, the networking, and the storage. But there's a lot of layers to the solution. There's a lot of layers because what are you going to run on top of these pieces of hardware? You need to run an operating system. You need to run a scheduler. You need to run management for the actual hardware. So there's many components that need to be considered. And then on top of that, NVIDIA has done a lot of investment on optimizing containers that have all the frameworks and tools needed to run these workloads in order to be able to quickly deploy them, which is something that sometimes we forget, right? We think, okay, so now we have the servers up, the GPUs are installed, the drivers are running, the storage is connected, we have the networking, it's all set up. Now, researchers go work. And the problem is that in many cases, they need to figure out how to actually load all the additional components they're going to need, all the libraries, and then optimize them for that particular infrastructure. Right? And so that has been taken care of in the deep learning and AI containers that we publish within NGC. So if you're not familiar with those, I would highly recommend that you take a look and play with them because they're very helpful. And then on top of that, there's a lot of knowledge that comes from our support groups that are already up to speed on these technologies and on the infrastructure. And so if you run into an issue, it's always easier to reach out to us or our partners and directly talk things out on the specific use cases that we've built for our customers. So, like I said, we did this for ourselves first, and so we built a huge cluster called Saturn V. And so this was kind of the basis for our reference architectures, in which we basically interconnected a number of DGX1 systems with storage and networking, and essentially made it a generic reference architecture, right? And so you can see here some of the specs, and you can actually download these reference architectures directly from our website. So it's a 20-30 page document that has a lot of specs and design criteria and definitions and explanations of why certain decisions were made, and then based on that, you can really follow the recipe and build your own. Okay. Now, what we've done is we've started working with our partners like DDN and developing solutions that fit with their storage solutions. And so in this case, we published a solution, and we'll talk a little bit more about it. But the idea is we're leveraging their really high performance storage solution to be able to feed all of the GPUs to really high performance networking in terms of leveraging new technologies like 100 gig E and Rocky and those types of newcomers to the marketplace. So the idea is you can basically leverage the architecture as it's published. It's, like I mentioned, like a 20-30 page document that describes not only the architecture but also the benefits. And they've already done a lot of testing, not just for deep learning and machine learning workloads, but also they've done testing for just the base I/O and throughput of the system. So it helps you both understand how it work with some of the workloads you've used in the past, but it will also help you understand how it will work with some of the more common deep learning and AI workloads that are available today and that you may be using as well when you start on the path of deep learning and AI. The idea is once you get this solution, you'll be able to just bring it in, start following the recipe. You'll have a big network of support from our side and from the DDN side, and you'll be able to get all your systems working in a short amount of time. Now, what do I mean by a short amount of time? What ends up happening is that in a lot of places, when people start investigating what they need to do about deploying those deep learning and AI infrastructure pieces or components, is that they need to do the research for the software engineering and the platform design. They need to go and find out if vendor X or Y will be able to provide the right components, right? And then you need to figure out how to integrate them. In a lot of cases, this integration sounds very easy because it's just cables you plug in. But the reality is that there's a lot of software involved, like drivers. Sometimes there's incompatibilities and things like that. And so those things need to be worked out over the time that you're implementing the solution. So in short, what ends up happening is that you end up spending a lot of cycles in doing your own research and working things out and troubleshooting. By the time you get here, what's interesting is, you have a solution that's working, it's really good, and it's perfect, but it's been 3 months since you started down this path, and this market is so fast, and so many things happen in 3 months that you figure out that you are better suited to run some other framework or some other algorithm that may need slightly different tunings or different infrastructure settings to be able to run that one. And so you need to do some additional research every time you deploy a new workload. And so you kind of go backwards a little bit, and then you have to, and then you try to get it done. So to wrap it up. So anyway, the point here is what we do is we do all that hard work for you. The idea is we eliminate a lot of those layers or a lot of those steps for you, so that you can really get things done in a very short amount of time. You basically have to invest, get the right equipment, and then we help you get the systems up and running with the right software. Like I said, those containers that you know from NGC really help, because that takes a huge chunk of that software research and deployment consideration out of the way. And you can get started within a week to do actual, to give your developers and your researchers all the infrastructure they need. And so, in a week you can cycle through and go back and start over. No problem. 3 months is a stretch. So anyway, just to summarize, some of the components that are in this reference architecture is we include the DGX1 as the compute piece with all the GPU capability. We have the DDN AI 200 and 7990 as examples of what can be used for storage with our super high throughput and high IOPS capacity, and then using 100 gig Ethernet or EDR InfiniBand to be able to give total throughput for data and inter-node communications. So that's it. So.